Hello, guys. Today, what we'll be doing is we'll be looking at some questions, okay, from GMAT, quant, and data sufficiency. So, before we start, we'll just wait for another 1 minute or 2 minutes in case someone else joins, and then we'll start. So, the plan is it's a mix of all topics, okay. So, I'll share a question. We'll first try. I'll give you a minute or so, and then we'll discuss that, okay. Then you can check whether your answer was correct or not. So we'll just wait for another minute and then start, okay. And after the session, if you feel like you want to have some sessions or any specific topics that you want to discuss, then you can directly text me on Leland, and we can set up a few lessons regarding, covering all those necessary topics, okay. All right, so someone's also joined, okay. All right, let us start now. All right, so this is the first one. You can see the timer running on the side. Yep, anyone? So let us discuss now, I think. So the worst possible way in which we could have at least tried doing it is just brute force calculated, okay? So it's not a nice way of doing it, especially since you are not allowed to use calculators in quant section. But so the brute force method is you just compute what is there in the denominator. So 2 squared we have got 4, or you can just write 2 squared times 5 squared is 10 squared, right? So that's 100 times this is 3 squared and 4 squared, so that's 12 squared, right? So 144. So you divide, okay. Now it's actually 14400. So if you divide like this, you're making things more difficult for you, because this is actually not needed. Whatever you get by dividing this, you just shift the decimal 2 places left. That should have been good enough, right? Okay, Lauren, you have answered. Okay, so we can do that, but I don't want to do this because I mean There's now no nothing special in this method, right? Anyone can do it. It will take a lot of time. Okay, both. So what we instead do is, I don't want to keep these fours and the twos and the fives. Okay, so if you know two and a five, obviously, like 2 times 5 gives you a 10, and that is the clue. Okay, see, this 2 square and this 5 square has already become a 10 square. Now I have a 4 squared, which is basically, what is 4 square? It's 2 squared whole square, right? So 2 raised to the power 4. If I have a 5 raised to the power 4, that would have given me another 10 to the power 4. So what I do is, I multiply 5 to the power 4 and keep the 3 square as it is. So what we have done is group these two first as 10 squared, rewrite 4 square as 2 to the power 4, introduce 5 to the power 4, okay, and 3 square is there as it is. 5 to the power 4, as you know, is 625. But the good thing is, all of this is gone. It's 10 to the power 4 and 10 squared, so 10 raised to the power 6. And the only job of 10 raised to the power 6 is shifting the decimal places, 6 places left. Whatever decimal is, shift it 10 plus 6 places left. So we can just ignore it for the time being. We just have to divide by 9. So we divide 625 by 9. It's a pretty easy division than what we had tried doing there, okay? So this would go how many times? 6 times. It will go 9 times. And then it will go 36 and then 4 again. So it will continue. And now 6 places if I move left. So I'm going to generate a lot of zeros, okay, like this. The question they asked is, how many distinct non-zero digits will it have? So zeros are anyways not useful, right? So how many distinct. So we'll not count the 4 multiple times. So distinct non-zero digits. There are only 3 of them, 6, 9 and 4. Is it okay? So we are basically used to our advantage the concept that 2 and 5 group together to give us 10, and dividing by 10 does not generate any new digits. It just shifts the decimal place. So we just needed to divide 625 by 9. Is the idea clear, everyone? So it's a concept of factors. All right. Anyone who has any problems, you can just put it in the chat. Okay. I'll be happy to explain again if needed. So since there is no one asking again, so I'll just move on, okay, to the next question. Oh, what happened? 1 second. Which one? Yeah. All right. So this is the next one. These are all actual test questions, means actual GMAT questions, by the way, official questions. I mean, not all of them, but the first one was, this is also an official question. Yep. Okay. So what do you think we need to be doing in this? So let us draw. Okay. Let's draw the diagram and see what we have. So in the xy plane, so let's draw the xy plane. So that's your xy plane. Let's say right angle is at P. PR is parallel to x-axis. X and y coordinates of PQR are integers from x varying from -4, and this is -2. Okay. There's 0. All right. Let's draw some vertical. 1 minute. All right. Just assume that these are all parallel lines. I'm just drawing the grids. Okay. Easier to understand. And x y is from 6 to 16. All right. So I'll have to like do it in a slightly um, narrower. Oops. All right, you get the idea, right? So basically, you have these grid lines. So now, somewhere you have got 6. Okay, so there are some lines here, 6, and in between some more, and you have 16. So let's say this is 6. I'm not drawing all of them. So here, how many lines do we have? So we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that, right? From -4 to 5. So from -4 to 0 is 5 points, and then 1 to 5 is 5 more. And 6 to 16 will have 11, because we'll be counting, right? 6, 7, 8, 9, 10, 11, like that till 16. So it is 16 minus 6 plus 1, basically. Here also 5 minus -4 plus 1. So 10 lines here, and here we have 11 lines. Now it is saying that you have to draw a PQR line in this grid so that P has the right angle and PR is parallel to x-axis. So if I take a P here, then PR could be anywhere here. I mean, R could be this side, on that side, anywhere. Okay, and Q would obviously be vertical somewhere there. Again, Q could be even lower. We for all that matters, we don't know how where it is. It could be anywhere, but it has to be vertically down P. Okay, I mean Q can't be there when P is here, right? It has to be along this line, and we have a right angle triangle. So they are asking how many ways these right angle triangles can be constructed. Right, that is the question. So now if I start searching for points, it's going to be very difficult because I have to search positions for P. Now if P is on top, then Q cannot be above it. Q has to be below. Similarly, P is at the bottom, then Q has to be above it. So we have to figure out, based on a particular P, what are the possible values of Q, what are the possible values of R, and figure it out. Instead of doing it that way, what I suggest is, if you have a grid, okay, like this, if I pick any two vertical lines and any two horizontal lines, I get a rectangle, right? I could also get a square, but that's okay. I mean, a square is also a special rectangle in a way. Once I have the rectangle, I can choose my P to be any of the four corners. P is here, and Q and R and Q could be there. If P is there, then R is here and Q is there. If P is here, then R could be on that side and Q would be on top. If P is there, then R would be on this side and Q would be on top. So I can basically choose any of the four corners to be my P and get four different triangles. So for every selection of a rectangle that I can from this grid, I can basically create four triangles, PQR. So to get a rectangle first, we need to select two horizontal lines and two vertical lines. For the vertical lines, you have 10 lines, you have to pick any two. For the horizontal lines, you have 11 of them, and you can pick any two. And for every rectangle, you can choose the point P in 4C1, four ways. So your answer is this. So you calculate now. 10C2 is 10 times 9 over 2 factorial. 11C2 is, sorry, 11 times 10 upon 2 factorial times 4. So that's out. So you got 9900. So that is the third option. Follow? So what I did was, instead of searching for points, I just figured out, let me create a rectangle, and then from the rectangle, create your right angle triangles. That's easy, right? Otherwise, I have to keep on searching how many possible values. So for the entire region, how many points are there? All of those could be values of P. And for every P, how many possible values of Q are there? How many possible values of R are there? And that a lot of counting will be involved, right? So I don't get into all that counting. Create the rectangle and then have your triangles. Just check if this made sense. In fact, this is actually a question also, like in a grid, how many rectangles are possible? So this is how you find out the rectangles. 10C2 times 11C2 in this grid. Anyone has any questions on this? Or is this fine? Is this fine? Ashley, you got it? Lauren, Emmanuel, yeah, okay, good. Siddharth, all fine? Good, good. Okay, let's move on. All right, another official question. Let's try that. All right, so let's take a look at this one. So it's clear that it's $2 is fixed. Okay, you have to pay $2 even if you don't travel at all. Plus, now you pay 75 cents for each half a mile or a fraction of half a mile there. Means what? So if you have traveled 0.5 miles exactly, then you pay 75 cents. But if you have traveled zero point 0.2 miles, then also you pay 75 cents, because you have traveled not half a mile but a fraction of half a mile. Okay, so for a fraction of half a mile also you'll have to pay 75 cents. Say again you travel zero point 0.5 miles, you pay 75 cents. If you travel 1 mile, then you would have paid 75 cents times 2, so $1.50. But if you did not travel 1 mile, but instead you had traveled, say first you traveled zero point 0.5 miles and traveled another zero point 0.3 miles, let's say, that means you traveled only 0.8 miles. That means for this you paid 75 cents. For this, which is a fraction of half a mile, right? A fraction of half a mile. Here also you are going to pay 75 cents again. Okay. Not on a pro rata basis, but for the entire half a mile it will charge. That's what they are trying to say. So you will still end up paying $1.50. Okay, that's the basic idea. So now, if I take some values and check, okay, that's the easiest way of doing this sort of a question. This is defined to be the least integer greater than or equal to x. Okay, so if I take a number, say box of 2.1, so this is called a box function. Okay, so it looks like a box. So box 2.1 is defined to be the least integer greater than or equal to 2.1. So that would be 3. Okay, box of 2.1 will be the smallest integer greater than 2.1. So what are greater than 2.1? 3 can be greater than 2.1, 4 can be greater than 2.1, and so on. But the smallest of them is 3. Okay, so that's what the box x function is defined as. They're saying which of the following is the charge for a trip that is r miles long. So the answers are in terms of r. So if r be 0.5, then you are going to pay $2 and 75 cents. So $2.75. Okay, so let us check. This is 2 plus 0.75 times r by 2. So 0.5 by 2 is 0.25. Okay, times 0.75, which is definitely less than 0.75. And if you take a box function, it's not going to become 2.75. Okay, so that is out of the question. That's wrong. Here also, it's clearly wrong, because it is saying for half a mile, you are going to pay 75 cents. So if you traveled for 1 mile, you would have paid double, right? Not half of 75 cents. It would be double of 0.75. So if you traveled r miles, it should have been 2 times 0.75 times r. So it should be 2r, not r by 2. So anything which talks about r by 2 is wrong. And here the 2r is missing. This is only r. So that's also wrong. So first 3 are straight away out. You don't need to really plug in numbers to check that. So the basic choice is between these two. Okay. So which one do we have? So if I take, let's say, let us say, the distance to be 1 mile, then your actual cost should have been $2 plus, for half a mile it's 75 cents. For 1 mile it will be 1.50. So it will be 3.50. So what does this one give us? Let's say, so our r is 1. So box of 1.5. The box function of 1.5 would be 2. So this is 2 plus 2, 4. So that is excess. That's wrong. What about this? 2 plus 0.75. 2 times 1. So box of 2 is just 2. So 2 plus 2 times 0.75. So that's 1.5, sorry. So that's 3.50. That matches with our calculation. So it is the fifth option. Okay. Yes, Emmanuel, you got it right. Good. All right. So I hope this was clear. Good enough. See, for these sort of questions, it's best to plug in values. Okay. So you have to understand by looking at a question, do I plug in a value and check, or do I actually solve this and check? Okay. So this is typically a question where you plug in values because the variable is defined in the question. How do you identify? So the variable is defined in the question. The same variable is present in each of the answer choices. So it's a classic question where plugging in makes a lot of sense. Okay. All right. Let's try another one. This is a permutation combination question. Yep. Anyone with the answer to this? All right. Let's check. So we have, forget the question. Let's say we have got, or let's take the same names. Okay. A is there, M is there, and let's say there are four others. Total 6 people. Now you have to divide this in two parts according to the question. 3-member team, another 3-member team. So if I ask you this question, that in how many ways can you do that? Like split them into two parts equally. Can anyone answer that? No need to calculate. You can just mention it in terms of NCR. Okay, let me ask you an easier question. In how many ways can you select 3 people out of that set of 6? It's simple, right? 6C3. So if there's 6 people, I can select 3 people out of them in 6C3 ways. That's 20 ways. Now look at this. Say out of A, M, P, Q, R, S, when I select 3 people, let's say I select A, M, P. So these 3 people are A, M, P. That means the other QRS is left over. Okay, left behind. But when I select 63, when I say when I say my answer is 63, there is a possibility that in that 63 I could have also got QRS, and my AMP could have been left behind. Okay, Manuel, I'll just check what your answer is. But let's just follow this for the timing. So I'm saying when I say 63, I can either select AMP and leave QRS behind, or I can select QRS and leave AMP behind, right? But now if the question is to divide them into equal groups, okay, if I to divide them into equal groups, and I say that my answer is 6C3, one of the answers will be AMP selected and QRS left out. So that is a two group division, right? The other is also QRS selected and AMP left over. So that's also a two group division, right? Equal. But both of them are actually the same split, right? Whether you have taken AMP and left QRS behind or taken QRS and left AMP behind, after all, it is the same selection. Same, not same selection, but then it's the same way you have split it into equal groups. So you're counting every case twice, right? You're counting AMP QRS two times. So to avoid that, what we have to do is, so total number of ways will be 6C3 divided by 2 factorial, or divide by 2. Let's just keep divided by 2. Okay. It's after all the same thing. Okay. And that is 10. So that means you can split the people in two equal parts. Total cases 10 ways. Now that is the total. Now you have to figure out the favorable. What's the favorable question? M and A should be together. So if A and M are together, I just need to choose one out of the remaining four who will be with them. Okay. I just need to select one out of the remaining four people who will be with them. So 4C1. So my answer is 4 out of 10. They are asking me to answer it in terms of percentage because all the answers are in percentage. So multiply with 100. So you have 40%. That is a third option. Okay. Emmanuel, I think I didn't understand the logic for 3C2 divided by 6C2. Why C2? You're thinking in terms of two groups, that's why 2. But we are not doing that, right? We are saying that from 6 people, see, logically speaking, you cannot select two groups from 6 people. You can select people from people. Since the two groups have equal number of people, we have to select 3 people from 6 people. So it should be 6C3, not 6C2. Okay. Yeah. And it won't be 6C3 also because 6C3 means we have double counted, as I told you just now. So it should be 6C3 divided by 2, half of that. You can actually list them down. Okay. If you list them down, you will get 10 cases only. Okay. I hope this was okay. You understood the logic behind it. Let's move on. This is again PNC. We'll just skip a few more and then come back if we have time. Okay. Let's try a mixture question. Okay. That's something pretty common. Just to get some variety, we have been doing PNC back to back. So let's try this. Okay, someone's answered B. Okay, let's see. So how do we do this? So it says iron and copper. Okay, so iron and copper, let's call it IC. Okay, Fe and Cu. Uh, one has 5:7, so let's call it A1, and A2 has 1:3. Now they're saying that you have to mix them in equal quantities by weight. So that means alloy 1 and alloy 2 should be equal. But here, if you look at this 5 plus 7, this, if I look at the total, okay, this is 12 and this is 4. They are not equal, right? One is 3 times as big. So to make them equal, just multiply 3. So this now becomes 3, 9, and 12. So now they are equal as it should be. Just add them. 5 plus 3. So you have 8 and 7 and 9. So 16 copper. So the ratio 8:16, 1:2. So that is the second option. Yes, well done. That's correct. Is this the method that you used? Or do you do some other way? In terms of fractions, maybe, right? Okay. But yes, this, yeah, okay. This is a nice little way. So the logic behind this is very simple. That when you see a ratio 5:7, what do you mean by this ratio? So you might say that out of 12 parts, 5 parts and 7 parts and all that, right? But I think in a slightly different manner. I say that, okay, 5:7 basically means that there was some number multiplied to 5 and some number multiplied to 7. Maybe, say, for example, this was 50 and 70, and we reduced it down to 5 and 7. Okay, so that means what I'm basically trying to say is 5 and 7 means it was 5x and 7x. What is the value of x? We don't know. And the second one, 1:3, is y and 3y, because something else could have cancelled out, right? The common factor. We don't know whether it's the same. Now this is 12x and this is 4y. We need to make them equal because the question says that they're mixed in equal quantities. So 4y should be 12x and y is 3x. Okay? So when I substitute y as 3x, this becomes 12x, this becomes 9x, and this becomes 3x. This is exactly the same thing what I did. The only thing what I dropped was I did not need to use x and y anymore. So for beginners, you can start thinking in terms of x's and y's and then plug in and substitute. It's still easier, okay? And then gradually, as you get enough practice, you can just drop the use of x and y's and then just directly work with the numbers. Okay, so this is one another slightly different way in which you can treat ratios rather than thinking in terms of part of a whole, because part of a whole can make things very complicated sometimes. Okay, okay, let's move on. All right, a bit of time and distance. Let's try this. All right. So anyone with this? So what does it say? John takes 20 minutes to walk every kilometer. Do we take 16 to walk every kilometer? In a race, David beats John by 240 meters. So what's the length of the race? So what's the concept of a race? When David beats the other guy John by 240 meters, what's the concept of a race? That one of the guys will finish at the finishing line, while the other guy at that point of time will be somewhat behind. That's the basic idea, right? So when you are measuring the loss margin, like by the distance loss margin, not the time loss margin, but the distance loss margin, by distance by which you lose a race, we are saying for the same time the difference in distance. So the moment we understand that it's the same time, so what we do is, so for John and for David, so this guy is 20 minutes 1 kilometer, and David is 16 minutes 1 kilometer. So if I want to make the time equal, so what's the LCM of 16 and 20? 80. So if I think of 80 minutes for both, that's 4 times. So this will be 4 kilometers, and this is 5 times. So that will be 5 kilometers. So that means in an 80-minute race, if there was one 80-minute race, then David beats John by 1 kilometers. Okay, or basically 1,000 meters in an 80-minute race. So the question now says that they did not. This David did not beat by 1 kilometer. He beats him by 240 meters. So if this has to, so if this had to be, let's say, 500 meters, means half of a kilometer, the time would have also been half, right, in the same proportion. So that's the idea we are trying to go by. So this is 240 meters. So then this would be how much? 80 divided by 1,000 times 240. So 192 by 10. Sorry, did I make a mistake somewhere? Oh, sorry. The question is the length of the race. I was calculating the time. Sorry. Oh, okay. That was not necessary. Okay. I didn't see the question at all. Yes. So I just redo it. So if I make the time 80 minutes, okay, I'll go back to the same question again. So we got David covering for 1 minute, 16 fives, right? 5 kilometers, and John covering 4 kilometers. So David beats John by 1 kilometer. Okay. Now, if this has to reduce to 240 meters, so the question is the length of the race, okay, not the time of the race. Sorry. So if this has to become 240 meters, 1 kilometer, so 5 will become how much? That's the question. So 5 times, right? So 240 times 5. So that would be 1200 meters, kilometers, sorry, meters, because it's 240 meters, right? 1200 meters. So convert it to kilometers. So 1.2 kilometers. Yeah. Second option. Sorry for that. Okay, I misread the question. So they had asked for the length of the race. Length of the race is obviously the distance that the faster person has covered. So in this case, David has covered. David has finished the race. John is 4 kilometers. John has only covered 4. That means John is 1 kilometer behind. So now this proportion is just 1 becoming 240 meters. So 5 becomes how much? That's the question. So 5 becomes 1200 meters. So from the options, that's 1.2 kilometers. Is that okay? So reducing it down into proportions or ratios rather than trying to set up equations and then solve an equation from that. Okay, that's what the target is. This is always easier. All right. All right. Let's try one on numbers, number properties. Let's try number 13. All right, let's take a look at this one then. So it's saying n is at least 2 more than the product of 6 consecutive positive integers. So any 6 consecutive positive integers is always, so like something like x times x plus 1 times like that, okay? It goes on. So 6 consecutive positive integers is always divisible by 6 factorial, okay? So it's a multiple of 720. So basically, this is a multiple of 720. And n is at least 2 more than this. So 720 plus 2 or plus 3 or plus 4 plus 5 plus 6. See, as long as this is 6 factorial, okay, divisible by 6 factorial, as long as you are adding 2, 3, 4, 5, 6, which are basically factors of 6 factorial, the result will always remain divisible by divisible by either 2, 3, 4, 5, or 6. Okay. But anyways, so now coming to the other question, they're saying, is this even? So it may be even. Say if I add 720 plus 2, okay, I multiply the numbers 1, 2, 3, 4, 5, 6, then added 2. So it's even. But if I multiply 1, 2, 3, 4, 5, 6 and add 3, then it will become odd. So is n even? So 1 is not sufficient. Maybe even, maybe odd. Number 2 says n square has no more than 3 factors. Means what? N square can have 3 factors, 2 factors, or 1 factor. It can't have no factors. If it has no factors, then n is 0. Okay, we are discarding that. Now how can you have 3 factors? 3, so you know the number formula for finding out the number of factors, right? So if it's a raised to the power x, b to the power y, etc., then x plus 1 times y plus 1 times etc., that's the number of factors. So if I have 3 factors, then the number must have been some prime squared. So it could be 2 squared 4, which has 3 factors, or it could be 3 squared 9, which has 3 factors. Could be even, could be odd. Okay. If it has 2 factors, it's a prime number itself, because only prime numbers have 2 factors. It could be 2 itself, which is even. It could be 3, which is odd. 1 factor has to be 1 itself, can't be anything else. 1 is the only number that has 1 factor, which is odd. So even or odd, can't say. So individually, both of them failed. So now we'll take a look at combining both. So it says that n is 2 greater than the product of 6 consecutive positive integers. So if it is 6 factorial, so 720 m, you are adding something to that, and that has, according to the question, no more than 3 factors, means that has 3 factors. Okay, so that means we are saying that this can be a perfect square. Okay, or it could have 2 factors. In that case, this is a prime. So if I have, let's say, m as 1, okay, so this case is ruled out because that's only for 1. Okay, so that's out. So if this is m as 1, so 720, and if I add some number to it and make this a prime number, it's possible, right? Now clearly, if I do that, this will be a prime number greater than 2, and any prime number greater than 2 must be odd. So if it is 2 factors, it is definitely odd. Okay, now we have to check the case where it has 3 factors. Now to have 3 factors, it must be a perfect square. So for example, if I have 729 is a perfect square, right? 27 square is a perfect square. So if my m is 1, okay, and since it is at least 2 greater, so if I add 9 to that, so 720 plus 9, so I would have 729, which is 27 square. So it can be, but that is again an odd number, right? So the question is n even? So we are always getting that n is an odd number, and we get it by combining the 2 statements, and hence the answer should be Option C. Okay, that's okay. All right. So let us go to the next question. This is percentages. Let me just check what else we have. Yeah, okay. We can do that one. Is a nice one. This is number properties again. Okay, let us try this one. Yeah, let's try this. All right, let's take a look at this one. So it says x is divided by 13. The quotient is y with a remainder 3. So x will be 13y plus 3, and x is divided by 7. The quotient is z with a remainder of 3 as well. So now they're saying x, y, z are all positive integers. So when y times z is divided by 13, what will be the remainder? Okay. So from here, we can clearly understand 13y plus 3 should be 7z plus 3. 3 cancels out. So 13y is equal to 7z. So that implies y over z is 7 by 13. That means y is a multiple of 7 and z must be a multiple of 13, right? That's how it can only, that's the only way this can happen. Okay. Now, if that be the case, and when you are multiplying y times z, then the result obviously is a multiple of 13, because z itself is a multiple of 13, right? Otherwise, how would you get 13 here? Okay. With all of x, y, z being positive integers, there cannot be fractions or decimals. So the only way this could have happened is if z itself is a multiple of 13. If that is the case, then this product is a multiple of 13. So when you divide, the remainder should be 0. So that is the first option. Where can we access the recording? I think you should get a link to your dashboard or something on your message where you can access the recording of this. If you want the deck, you can just message me, okay? Text me on this on Leland itself, and then I'll send you across the PDF of this thing. I hope all the questions were clear. The previous one was okay, right? I mean, I just moved on quickly there. Anyone has any doubts with the previous one? This one that we did? One second, where did that go? Yeah, this one. You got the idea, right? Like three factors, two factors, one factor. How did we come to that conclusion? Using this property, the number of factors is power plus one. You add one to the exponent and multiply. Since three is there, it can only be from prime squared. There's no other way it can happen. And if you are, when you are combining two greater than the product of six consecutive integers, can be a perfect square, which is non-prime, like 27 square, or could be some 28 square, depends. But then all of them would have more than three factors, right? Because they are not prime. So those are straight away ruled out. What is the only thing left is the one with two factors, which is a prime case. So as I showed you here, like 720, a multiple of 6 factorial, 720 plus something, you can always generate a prime number in the 700s, right? I mean, there could be hundreds and thousands of prime numbers in that greater than 720. So you can just keep on adding something and keep on getting new prime numbers. So that's the only case that is possible. So that's why we said that it is option C. But in order to answer this question, you need to know this property. Okay. Any other question that you have doubts in? Anyone has any doubts in? You guys can try these remaining questions, okay? And if you want, you can get back to me if you have doubts on any of them. Then I can help you out, maybe with a text note or something. Okay. Regarding any classes, if you want to prepare for your GMAT, you can message me directly. I can help you with different course offerings. Okay. And if you found that this session was helpful, then do drop in a small review or rating, anything that works. Okay, I'll send you across a message with the link. Okay, thanks everyone then. Bye.